This is a video walkthrough for the Unit 5 review on the polar coordinate system. In 1 through 9, we're asked to find the point that corresponds to each polar coordinate pair. So, in number 1, the point is 3, 150 degrees. Find the 150 degree spoke and move 3 units out. That's point B. For number 2, we're asked to find the point 3, negative 60 degrees. So we have to rotate here from the polar axis negative 60 degrees and move 3 out from there. That gives us point L. For 3, we're finding the point negative 3, 90 degrees. If we find the 90 degree spoke, then move in the opposite direction 3 from there, that brings us to point M. For number 4, the point is 3, negative 135 degrees. So we're rotating 135 degrees clockwise, and if the radius is positive 3, that brings us to point O. For number 5, we're finding the point 3, 450 degrees. So if I rotate 360 degrees, that's a full revolution. An additional 90 degrees will bring us to 450. That's the point E. For number 6, we have a negative angle, negative 210 degrees. So I need to rotate 210 from the polar axis in a direction that's clockwise. That brings us to point B. But point B has a positive radius, so for a negative radius we'll go in the opposite direction, which brings us to point J. For number 7, we have the point 3, negative 240. So we need to rotate negative 240 degrees, which is a half turn and an extra 60, and that brings us to point D. For number 8, negative 3, negative 120 degrees. We want to rotate negative 120 degrees, and that will be 90 plus an extra 30. That brings us to point N, but the radius is negative, so we're in the opposite quadrant at point F. For number 9, negative 3, positive 135. So we're going to rotate to positive 135, and if the radius is negative, we're in the opposite direction, which brings us to point K. For 10 through 11, we're converting from polar to rectangular form. So this is polar r, theta, and the x value is equal to r times the cosine of theta, which is 10 times the cosine of 135 degrees, or 10 times the square root of 2 over 2, but negative because we're in quadrant 2, and so that gives us an x value of negative 5 times the square root of 2. The y value is r times the sine of theta, which is 10 times the sine of 135 degrees, or 10 times the square root of 2 over 2, or 5 times the square root of 2. So in x, y form, this is negative 5 times the square root of 2, 5 times the square root of 2. So we need to give our answer as an ordered pair in x, y form. In number 11, x is r times the cosine of theta, and the cosine of 330 degrees is the square root of 3 over 2. Multiplying, that gives us the square root of 9, which is equal to 3. And the y value is equal to r times the sine of 330 degrees, or r times the sine of theta. And the sine of 330 degrees is negative a half. So that gives us a y value of negative root 3. So in x comma y form, this is 3 comma negative root 3. For number 12 through 13, we're converting from rectangular to polar. So that means we have a point that's in x comma y form, and we're looking for r comma theta form. And we want specifically r to be a positive number and theta to be somewhere between 0 and 360 degrees. So we can find the r value by using r squared is x squared plus y squared, which is 0 squared plus negative 3 squared, which gives us 9. So if r squared is equal to 9, then r must be 3 if r is positive. To find the value of theta, we can use tangent of theta is equal to y over x, and tangent of theta is equal to negative 3 divided by 0, which is undefined. Tangent is undefined for 90 and also for 270 degrees, but we need to choose one of them, and we're going to choose that based on the location of x comma y. 0 comma negative 3 is down from the origin or down from the pole, so we're going to choose 270 degrees. So the point in r comma theta form is 3 comma 270 degrees. For 13, r squared is equal to x squared plus y squared, which is negative root 2 squared plus negative root 6 squared, or 2 plus 6, which is 8. So if r squared is equal to 8, then that means that r is 2 times the square root of 2. To find the value of theta, tangent of theta is equal to y over x, which is negative square root of 6 divided by negative square root of 2, which is positive square root of 3. Tangent of theta is equal to positive square root of 3 for 60 degrees and also for 240 degrees. However, this point in x comma y form is in quadrant 3 since x and y are both negative. That means we're going to choose the 240 degrees. So in r comma theta form, this is 2 square root of 2 comma 240 degrees. In 14 through 19, we're converting each rectangular equation to polar form and solving for r if possible. If not possible, we will solve for theta. So x can be changed to r times the cosine of theta, or r cosine of theta can be substituted for x. Now we can solve for r by dividing by the cosine of theta, and 4 divided by the cosine of theta is the same as 4 times the secant of theta. So in polar form, the equation of that vertical line is r equals negative 4 times the secant of theta. For number 15, y is equal to negative x. It's easiest to convert this one if we divide both sides by x. In doing so, we get y over x is equal to negative 1. Y over x can be replaced by tangent of theta, and now since this equation cannot be solved for r, we can solve it for theta instead. Tangent of theta is equal to negative 1 has two solutions on the interval from 0 to 360. We can choose either one of those. Tangent is negative in quadrants 2 and 4, so we can choose either theta is equal to 135 degrees, or we can choose theta is equal to 315 degrees. Either one of these is fine. You don't need to state both. Pick one. For number 16, this is the equation of a line in standard form. To convert it to polar, replace x with r times the cosine of theta, replace y with r times the sine of theta, factor r, and divide by 3 times the cosine of theta minus 2 times the sine of theta. In number 17, this is the equation of a circle not centered at the origin. It's easiest to convert if you expand x plus 6 squared, or multiply it. That gives us x squared plus 12x plus 36 plus y squared is equal to 36. If we move our terms around a little bit, we have x squared plus y squared plus 12x is equal to 0 because we subtract 36 from both sides. And let's move the 12x to the right side of the equation. X squared plus y squared can be replaced with r squared, and x can be replaced with r times the cosine of theta. To solve for r, it's easiest to do if we just divide both sides by r. So r is equal to negative 12 times the cosine of theta is the equation of that graph in polar form. In number 18, x squared plus y squared is equal to 25. X squared plus y squared can be replaced with r squared. To solve for r, we can take a square root. Truly, there are two forms that are equally acceptable, r equals 5 or r equals negative 5. We're probably just more likely to go with the positive value. In number 19, we have the equation of a line. Lines are most easily converted into polar form if written in standard form first. So multiply through by 4. Move the 5x to the left side of the equation. And now we have a standard form equation. X can be replaced with r times the cosine of theta, and y can be replaced with r times the sine of theta. Factor r. And divide both sides to solve for r. In 20 through 25, we're converting each polar equation to rectangular form and solving right in the standard form for each graph. Sometimes that means solving for y, sometimes not, particularly when we have the equation of a circle. If r is equal to negative 3, it's easily converted if we square both sides. Then r squared is equal to 9, and x squared plus y squared is what can replace r squared, so x squared plus y squared is equal to 9, which is the equation of a circle centered at the origin. In number 21, if theta is equal to 210, the easiest way to convert this one is to take the tangent of both sides of the equation. Tangent of theta can be replaced with y over x, and tangent of 210 degrees is positive square root of 3 over 3. And multiplying by x, y is equal to the square root of 3 over 3 times x, which is the equation of a line that's passing through the origin with a slope of 3 times the square root of 3. In number 22, we can multiply both sides by the denominator to clear fractions. And then distribute the multiplication times r to the addition on the inside of the parentheses. Once we do that, r times the cosine theta can be replaced with x, r times the sine of theta can be replaced with y, and now we have the equation of a line that can be written in standard form. You can solve that for y if you wish, but that's already in a standard form for the graph, so that's fine in its present form. For number 23, r is equal to 8 times the cosecant of theta. That's best rewritten as 8 divided by the sine of theta. Now if we clear the fraction by multiplying through by the sine of theta, we get r times the sine of theta is equal to 8. r times the sine of theta can be replaced with y, so the equation in rectangular form is y equals 8, which is the equation of a horizontal line. For number 24, r is equal to 2 times the cosine of theta. R is not easily converted, nor is cosine of theta by itself. It's easiest to convert if you multiply both sides by r, Once you do, r squared can be replaced with x squared plus y squared, and r times the cosine of theta can be replaced with x. This is not quite in standard form. It is an equation for a circle, but we can put it in a standard graphing form by subtracting 2x from both sides, and then completing the square on x squared plus minus 2x plus blank. And if we add to the left side of the equation, we must add to the right. If you want to draw a square to complete the square, x squared minus 1x minus 1x plus blank. The factors must be x minus 1 times x minus 1, and the literal completion of that square is negative 1 times negative 1, which is positive 1. Now factoring x squared minus 2x plus 1 factors into x minus 1 squared, and then plus y squared is equal to 0 plus 1, which is 1. Now that's in the standard graphing form for the equation of a circle. Not necessary to say, but the center of this circle is the point 1, 0, and the radius is 1. The radius is the square root of the number on the right side. All right, let's take a look at number 25. R is equal to negative 14 times the sine of theta. Multiply both sides by r. And replace r squared with x squared plus y squared, and r sine theta with y. Let's bring the 14y to the left side of the equation, and then complete the square. If you want to draw a square, to actually help with complete the square, we have y squared plus 14y, which divides into 7y and 7y. That means that the factors of this polynomial are going to be y plus 7 times y plus 7, and the literal completion of the square is 7 times 7, or 49. So we'll add that to both sides of the equation, and then factoring y squared plus 14y plus 49 is y plus 7 squared, and that equals 49. That's in a nice standard graphing form, which can tell us that the center of the circle is at the point 0, negative 7, and the radius is 7, which is the square root of 49.